Earth's shaking giants. What is an earthquake? Earthquakes are powerful events. They shake the ground beneath our feet. Imagine a giant shaking a rug. That's what an earthquake feels like, but on a much larger scale. These tremors are caused by the movement of massive pieces of Earth's outer layer, known as tectonic plates. These plates are constantly moving, albeit extremely slowly. Sometimes they get stuck together due to friction. This buildup of pressure is like pulling back a rubber band. When the pressure becomes too great, the plates suddenly slip, releasing a tremendous amount of energy. This sudden release of energy is what we feel as an earthquake. It can cause the ground to shake, tremble, and even split apart. The intensity of an earthquake can vary widely, from barely noticeable tremors to catastrophic events that can level entire cities. Shifting plates, the driving force of earthquakes. To understand earthquakes, we need to delve into the heart of our planet. The Earth's outer layer, called the lithosphere, is not a single solid piece. Instead, it's broken into several large pieces like a giant jigsaw puzzle. These pieces are the tectonic plates. These plates float on a layer of semi-molten rock called the asthenosphere. Convection currents within the Earth's mantle, driven by heat from the core, cause these plates to move, albeit extremely slowly, at a rate of a few centimeters per year. This movement is what causes most earthquakes. The edges of these plates, called plate boundaries, are where the action is. It's here that plates collide, pull apart, or grind past each other. These interactions are the primary source of the pressure buildup that leads to earthquakes. Stored energy unleashed. How earthquakes happen. As tectonic plates move, they generate enormous amounts of pressure at their boundaries. This pressure builds up over time, like air being pumped into a tire. The rocks along the fault line try to resist this movement, but eventually the stress becomes too great. When the pressure exceeds the strength of the rocks, they break. This break or rupture occurs along a fault, which is a fracture in the Earth's crust. The point where the rupture begins is called the focus or hypocenter of the earthquake. The point on the Earth's surface directly above the focus is called the epicenter. The sudden release of energy during an earthquake propagates outward from the focus in the form of seismic waves. These waves travel through the Earth's interior and across its surface, causing the ground to shake and vibrate. The intensity of shaking decreases with distance from the epicenter. Section 4. Waves of destruction. The impact of seismic waves. The energy released during an earthquake travels in the form of seismic waves. Think of these waves as ripples spreading out from a stone thrown into a pond. There are several types of seismic waves, each with its own characteristics and effects. The two main types of body waves are primary waves, or P waves, and secondary waves, or S waves. P waves are compressional waves that travel the fastest, causing the ground to move back and forth in the direction the wave is traveling. S waves are shear waves that travel slower and cause the ground to move side to side, perpendicular to the direction of wave propagation. Surface waves travel along the Earth's surface and are responsible for most of the shaking we feel during an earthquake. These waves are slower than body waves but have a larger amplitude and can be extremely destructive. Section 5. Understanding earthquakes. The key to minimizing their impact. Earthquakes are a stark reminder of the immense power of nature. While we cannot prevent earthquakes, we can strive to mitigate their impact. By understanding the science behind earthquakes, we can develop better building codes, early warning systems, and disaster preparedness plans. One of the most important aspects of earthquake mitigation is earthquake-resistant infrastructure. Buildings, bridges, and other structures can be designed to withstand the ground shaking caused by earthquakes. This involves using flexible materials, reinforcing structures, and implementing base isolation systems. Early warning systems are another crucial tool in earthquake preparedness. These systems use networks of sensors to detect the first signs of an earthquake and can provide seconds to minutes of warning before the strongest shaking arrives. This precious time can allow people to take cover, stop critical infrastructure, and prepare for the aftermath. Finally, public education and awareness are paramount. By understanding the risks associated with earthquakes, people can take steps to prepare their homes, families, and communities. This includes having an emergency plan, securing heavy objects, and knowing how to drop, cover, and hold on during an earthquake. Please like this video and subscribe to our channel for more amazing content.